Hi dear students, welcome to my video class. Today I will continue the discussion of chemical kinetics with another video. The topic is catalyst. Catalyst will be discussed in the 5th chapter, particularly in the surface chemistry. Therefore, you will learn more about the catalyst and different types of catalysts from that topics. Here we will discuss catalyst and its property in chemical kinetics, particularly speed of the reaction. Okay. Catalysts have different classifications. I introduce you one classification here. That is negative catalyst, autocatalyst and positive catalyst. Positive catalyst is the material which increase the rate of reaction. I agree one thing. In general sense, the word catalyst is used for positive catalyst. But you don't forget, we have negative catalyst also. Negative catalyst is a chemical substance which is added to the reaction mixture to suppress the speed of the reaction. We need such a situation. If you want to suppress a reaction, you add the negative catalyst. Autocatalyst is another rare idea where one of the products in the reaction will act as the catalyst. I think you will have this experience. When you do the titration of KMnO4 with oxalic acid in the presence of H2SO4, initially the disappearance of the color will be slow. But when reaction proceeds or towards the end point, you will notice that even a single drop of oxalic acid will have great color change. This is because MnSO4, the quick color change, because MnSO4, one of the products, will act as the autocatalyst. Positive catalyst, we have bunch of examples. We will discuss in future. IN for Haber process, V2O5 for 1,1,D pentoxide for contact process. Negative catalyst, Haber process have a negative catalyst, H2S. Contact process have a negative catalyst, arsenic oxide. Okay. Now I will discuss you some characteristics of catalyst. One is, catalyst does not initiate the reaction. Catalyst cannot initiate the reaction. It increases the rate of reaction only. Small amount of catalyst are required. We don't need a huge amount of catalyst, only small amount, because it does not take part in the reaction or it does not consume in the reaction. It is not consumed. You will get the catalyst back once reaction is over. Therefore, only small amount is required. And it does not change the equilibrium. The only thing catalysts do that, you will get the equilibrium fast. The time for reaching equilibrium will be shortened. Okay. It changes only activation energy. Fine. Now, I have assured you in previous videos, I will discuss more about the activation energy. Therefore, catalyst only changes activation energy. Therefore, we can discuss in detail what is activation energy. It is the extra amount of extra energy required for the reactants to lead its collision for the productive formation. It is extra amount of energy required for the reactants to make its collision effective. Another sense, or to lead its collision for the productive formation. You can use make collision effective. Make collision effective. This is extra energy required to make the collision effective. Okay. Activation energy is equal to threshold energy minus actual energy of reactants. Now one question arises, what is threshold energy, TE? What is TE? Threshold energy, T. It is the energy barrier to be crossed by reactant molecules before converted into two products. Okay, this is a limit of energy barrier that should be attained the reactant molecules before converting to the products. Therefore, our reactant have a lower energy and there will be a higher energy position like this. This is threshold energy, this is actual energy of the reactants. Therefore, this gap must be filled. That is called activation energy. Fine? Okay. We can draw the graph. Consider a reaction. A gives P. You draw an energy profile diagram like this. Okay. This is energy axis. This is reaction coordinate or reaction axis. Reaction coordinate. Now, suppose A, and here your P, products. You know, the reaction will be like this. This is our energy barrier, and this is called the threshold energy. This is the energy of reactant, and this is the energy of product. This is reactant, this is product. You know, EP minus ER, that is delta H. EP less than ER, therefore delta H negative. This reaction is called exothermic reaction. Therefore, it is an exothermic reaction. What is the trick for exothermic reaction? P should be down than A. This is exothermic. This change, suppose this change, exothermic. A to P is exothermic. A to P is exothermic because this is delta H negative. Now, what is our activation energy? This is activation energy, E. TE, suppose this is 0, TE, this is a TE value from 0 to TE. 0 to ER is the energy of reactant, ER to TE is the activation energy. Therefore, TE is equal to ER plus activation energy, or activation energy is equal to TE minus ER. And if you remember, what is delta H of the reaction? Delta H of the reaction is EP minus ER. And it will be negative for exothermic reaction. Fine. Suppose I draw the endothermic graph of same reaction. Same reaction. This is your R and this is your P. Endothermic means now the product is reactant, R is the P is reactant. Okay. This is the now P is the reactant now. Remember, R is the product. This is ER, energy of R. This is energy of P. For time being, this is a reactant. And this gap is delta H. This gap is delta. What is delta H here? This is backward. Delta H backward, B. Is equal to, please write ER first because final, your change is towards R. Final minus initial, EP, that is positive. You know what is the activation energy of this backward reaction? This is activation energy of backward. I put it is activation energy of forward. What is activation energy of forward? Yes, this is. Fine. Which is higher activation energy? Whether EF or VB. Remember, EB greater than EF. Am I correct? Yes. For that, you just think from here. Just think from here. This is your EF. EF, if the change is towards here. This is a forward reaction because already it was mentioned A gives P. Okay. Therefore, activation energy of forward is less than activation energy of backward. Do you remember activation energy of forward plus enthalpy of reaction? Now here also you can draw activation energy of backward. What is activation energy of backward? This is activation energy of backward. Activation energy of backward is equal to activation energy of forward plus, one minute, let's switch off. Yeah, more. Activation energy of backward is equal to activation energy of forward plus enthalpy of reaction. Very, very important. Activation energy of backward is equal to activation energy of forward plus enthalpy of reaction. Yes, enthalpy of reaction. Very, very important. Now, this is for exothermic reaction, remember? For exothermic reaction. Okay? I said you this exothermic reaction. Now, remember one point. For an exothermic reaction, you have to listen very carefully. For an exothermic reaction, if activation energy of forward is 0, will activation energy of backward 0? Will activation energy backward 0? No. If activation energy of forward is 0 for an exothermic reaction, the activation energy of backward will be equal to enthalpy of reaction. Remember, for an exothermic reaction, the minimum activation energy of backward reaction is enthalpy of reaction. The minimum activation energy of backward is enthalpy of reaction. Now these graphs are very important. If you draw an exothermic reaction, please draw reactant up, product down. Enthalpy of reaction will be negative. Activation energy of forward will be shorter than activation energy of backward. Activation energy of backward will be is equal to activation energy of forward plus activation enthalpy of reaction. That is for exothermic reaction. Okay. For if you draw endothermic reaction, if you want to draw an endothermic reaction, just reverse energy of the products. Now the product is R, which should be greater than energy of reactants. Just reverse. Therefore, you just learn this thing reverse for endothermic. Okay. This is all about the actuation energy and energy of reactants. Now, what is catalyst doing? Effect of catalyst. Effect of catalyst on activation energy. We can beautifully articulate this effect in a graph. Okay. Reaction, energy. I write a exothermic reaction. I write an exothermic reaction. How do you write exothermic reaction? The energy of reactant should be greater than energy of products. I will get a graph like this. Obviously, this is activation energy. Now I add some catalyst. You know what happens? Same reactant, same products. But what happened, the activation energy decreased. Now what is activation energy? This EC. Therefore, E is equal to activation energy of uncatalyzed reaction. EC is equal to activation energy of catalyzed reaction. Catalyzed reaction. Obviously, is C less than E. Now, suppose K, rate constant of A into e raised to minus E by RT. Rate constant of catalyzed reaction is equal to A into e raised to minus EC by upon T. EC upon T. Equation number 1, equation number 2. Therefore, Kc by K and A cancel. E minus EC by RT. Very, very important. What is E? Activation energy of catalyzed, EC, and E uncatalyzed, EC catalyzed. Remember, E uncatalyzed, EC catalyzed. Now, Kc by K is the number of times of reaction increases. Okay. How many times of reaction increases? Directly proportional to value of E minus EC. Value of E minus EC. If E minus EC, that is this difference is higher, Kc by K will be higher. Do you agree? If E minus EC is higher, Kc minus K will be higher. Therefore, higher this value, higher the number of times reaction increases. Okay. Now, I go to another concept, very important concept. Suppose a reaction A gives B, its rate increased to a value by adding catalyst. Rate or rate constant. Okay. Same rate constant or rate achieved by increasing temperature without catalyst. Without catalyst. Therefore, same reaction, you have A gives B, another bottle A gives B, same speed, here catalyst, here temperature. In one case you have added catalyst, in another case you have added temperature. Therefore, this is rate constant Kc, this is Kt. Therefore, Kc is equal to Kt. Rate constant with the catalyst is equal to rate constant with temperature. Therefore, A into e raised to minus Ec by Rt is equal to A into e raised to E by Rt. T dash, put T dash. Okay, a different temperature. And A cancelled. Therefore, you know, it's very, very important. These terms are equal. Therefore, you can have a very beautiful relation. E catalyzed by T is equal to E by that particular temperature. Very important concept. Very important concept for solving the numericals. I hope this video is helping you. Please watch it. Any doubts, please message me. I will meet you. I will clear your doubts. Thank you for watching.